Hello everyone, my name is Kanushri. Before we dive into our AP Statistics Masterclass, I'd like to take a moment to introduce you to the organization that's making this session possible. Let's Unbound. Let's Unbound is dedicated to empowering students across more than 25 countries by fostering STEM skills, life skills, and college readiness. Our mission is to help students achieve their life skills by 18 and life goals by 35 through personalized learning and mentorship. With programs ranging from skill development, gifted test, college prep, to Ivy League readiness, Let's Unbound has taught over 4,000 students, conducted more than 125,000 hours of teaching, earned a global 4.9 out of 5 rating. By combining innovative teaching methods with strong mentorship, Let's Unbound helps students realize their potential and make a positive impact on the world. So as we begin today's masterclass, remember, you're building skills that will help you excel far beyond the test in college, career, and life. Over to you, Harsh.
Yeah, thank you, Kanushri. I am Harshvardhan Phatak. I am a mentor with Let's Unbound for the AP Statistics curriculum. And I will be talking about the AP Statistics exam in general, the test structure. I'll be talking about the type of preparation which is required for the AP Statistics course. And I'll also talk about the nitty-gritties of the examination. Okay, so let me start by the introduction to this course. So the AP Statistics course introduces students to the major concepts and tools which are used for collecting, analyzing, and drawing conclusions from the data. Now, you would see that in today's world, whichever domain of knowledge you are trying to pursue your degree, okay, these skills are very, very important. Okay, collection of data, analyzing data, and drawing useful information from the data would be a skill that would be sought after by most of the organizations. The AP Statistics curriculum, therefore, is divided into 4 themes which are evident in the content, skills, and assessment. Okay, in terms of number 1, exploration of the data. Okay, so part of the examination focuses on a student's ability to go through the data which is provided in the form of graphs and tables, explore the data, and churn out meaningful information from that data. Sampling and experimentation is the second theme. Now, this introduces the student to the concept of statistical analysis. It includes the concept of a statistical survey as well as a statistical experiment. So it takes you through the different processes of surveys. It takes you through different types of experimentation techniques. And there are questions on the exam which focus on the different methods which are used by statisticians in doing so. If you look at the different curriculums which are followed across universities and across courses, again, a statistical survey technique or a statistical experimentation methodology would be very important skill for a student to have. The third theme on the AP Statistics course is the concept of probability and simulation. Now we see that more and more modeling kind of courses have been introduced in different universities, again, in almost all the domains of knowledge. So concept of probability, concept of simulation, and doing a statistical analysis which is probabilistic in nature is very, very important skill to gain. So the AP Statistics also includes questions which are based on the probability and simulation techniques. Finally, statistical inference would be a little advanced statistics where we learn how to test the hypothesis, the claims which we make about a population based on our sample studies. So all these 4 themes, they combine very nicely into the entire curriculum of the AP Statistics course. Students make use of technology, investigations, problem solving, and writing as they would build the conceptual understanding as well as the practical problem solving skills related to all the 4 themes. Now, talking about the AP curriculum in general, the AP Statistics course, it is equivalent to a 1 semester introductory non-calculus based college course in statistics. Okay, so AP Statistics course therefore provides an excellent option for any secondary school student who has successfully completed a second year course in algebra, okay, the algebra 2, and who possesses sufficient mathematical maturity and quantitative reasoning ability. So if you get a good score on the AP statistics, these are the skills that you are likely to showcase, that you have sufficient mathematical maturity and quantitative reasoning ability. So because second year algebra is a prerequisite course, AP statistics is usually taken in either the junior year or the senior year. Students who are planning to take a science course in their senior year will greatly benefit by taking the AP statistics in their junior year itself. Okay, for students who otherwise take no mathematics or have not taken mathematics in their senior year, the AP statistics actually allows them to continue to develop their quantitative reasoning skills. The students who wish to leave open the option of taking calculus in college should include pre-calculus, obviously, in their high school program, and perhaps take AP statistics concurrently with the AP pre-calculus. Okay. Now, students with the appropriate mathematical background are encouraged to take both AP statistics as well as AP calculus in the high school. So, in a way, it caters to a different kind of crowd right from the junior year to the senior year. Okay. Or it finds its utility for all types of students. Now, talking about the different domains of knowledge, who should opt for AP statistics? So, it is a beneficial course for students with diverse interests. Okay. So, for example, somebody who is wanting to take up engineering sciences, it's a great option to build a solid foundation in algebra and enjoy working with data and modeling. It is a must course if you plan to get into engineering design, data sciences, etc. Talking of a very different stream altogether, psychology. If you want to get into psychology, so understanding statistical methods and experimental design is very crucial for analyzing research data in psychology as well. Okay. Be it doing practical experiments, be it doing survey-based results. Okay, you would need all that knowledge if you are pursuing courses or studies in psychology. Business AP statistics helps with market research, data analysis, and understanding the different business trends. So if you are following a degree in business, okay, analyzing the market, analyzing the data related to market, financial trend analysis, etc., you would again you'd again need a good and a solid foundation as far as the statistics knowledge is concerned. Talking of economics, so statistical analysis is a fundamental for all types of economic research and modeling. We see that there are various options, multiple options which exist not only with the government jobs or with the private sectors, but there are a lot of jobs which are there as far as research based content is concerned in economic stream as well. So all of these things, they require a solid foundation once again in terms of statistical analysis. So AP statistics can play a very important role if you're planning to build a career in economics as well. Talking of other social sciences, so sociology, political science, and other social sciences also rely heavily on statistical methods for all the research and the analysis that is done. Okay. Particularly, you would see a lot of surveys taking place in these domains, and therefore a sound knowledge of the survey techniques is very important. Again, an AP statistics course will give you that footing in terms of social sciences as well. Biology and other sciences, once again, AP statistics can be a valuable foundation for understanding experimental design, data analysis in scientific research. Okay. For example, in the field of medicine as well, we see that when companies introduce vaccines or they introduce medicines, okay, statistics plays a very important role in terms of designing an experiment for testing the efficacy of those medicines, okay, and those vaccines, etc. So it is related to core sciences, it is related to social sciences, it is related to business and economics. So any kind of domain that you want to pursue your career into, statistics is going to be an important part there. And therefore, taking up an AP statistics course will greatly improve your chances of securing an admission if you have a good score on this particular exam. Now, coming to the curriculum or the syllabus for this particular test. So you can see the entire syllabus for this test has been divided into 9 units. Okay. If you can see that these 9 units are related to the 4 streams that we were earlier discussing. So for example, Unit 1 and Unit 2, you can see, are totally focused on exploration of the data. Unit 1 talks about exploration of one variable data, okay, where we talk about the different graphs and tables, as I said, whereas Unit 2 is more focused on exploring two variable data. So trying to find out a connection between or a relation between two different data sets. Okay, so we study the concept of correlation and regression in the second unit, and we try to find practical examples where we can apply this concept of correlation and regression analysis. Unit 3, we move on to statistical surveying methods. So collection of data, formulation of experiments, how to perform those experiments, how to interpret the results of a survey, how to interpret the results of a statistical experiment. All of that part is covered under unit number 3. From unit 4, we start with the basics of probability. So we talk about the random variables. We also talk about the probability distributions. So we talk about the continuous variable, the discrete variable, and the different applicable probability distributions. Now, this unit actually lays the foundation for all the forthcoming units in this particular syllabus. You can see unit number 5 is totally based on sampling distribution. Now, sampling distribution, as we can see, are types of probability distributions only. So, if you don't have a sound knowledge of probability and probability distributions, which we cover in unit number 4, it would become very difficult for you to manage unit number 5 and all the units that follow unit number 5. Because after this, all the units are like progressively linked to each other. So unit 5, we talk about the sampling distribution. So basically unit 5 is like a combination of unit 3 and unit 4, because unit 3, we've learned how to perform the sampling. Unit 4, we've learned how that sampling is related to probability and distributions. And in unit 5, therefore, we study the different sampling distributions. So there are sampling distributions of mean, there are sampling distributions of proportions, there are sampling distribution for differences of mean, etc. All of that part we cover in unit number 5. Unit number 6, 7, 8, and 9. This is a major chunk of your syllabus. I would say the most important part of your syllabus, because in all these 4 units, we discuss the concept of hypothesis testing or statistical inference, as we call it. So theory of estimation and theory of inference is considered in all these 4 units, the 6, 7, 8, and 9. Unit number 6 is based on inferences for categorical data. So there are inferences which are based on population proportions. Unit number 7 is more of quantitative data. So there are inferences which are based on means and difference of means. Then unit 8 is a very special unit where we talk about, once again, the categorical data. We talk about tests which are related to a statistic called the chi-square statistic. So there is test of independence, which is very important part of that unit number 8. And unit number 9 is all based on inferences for regression coefficients, or the quantitative slopes, as we call them. If you look at the exam weighting, okay, so you can see maximum weightage is for unit number 1, which is the basic exploration of one variable data. As I said already, where we cover all the different types of graphs, tables, and representation of data. So you have almost 20% weightage, in fact, more than 20% weightage for the first unit. Then unit number 3, which introduces the concept of sampling and experimental design. It also has a weightage of close to 15%. And then the probability-based topics have a weightage, a combined weightage. You can see if I just take the unit 4 and 5, the distributions and probability, that itself is close to 30%. So that makes probability and probability distribution one of the most important topics. And then all those inference-based units, collectively, you can see they also contribute almost 35% to the entire syllabus. So that is how all those 4 themes that were mentioned in the previous slide by the College Board, they are distributed across the 9 units of the syllabus. Talking of the structure of examination, so this is the basic structure of the AP Statistics exam. Okay, you have, as is the case with almost all the APs, you have 2 different sections. One is based on the multiple choice type questions, the MCQs, and the other one is based on the free response questions, the FRQs. The multiple choice questions, okay, you get 90 minutes to answer all those questions. Whereas the free response questions, once again, you get 90 minutes to answer all the free response questions. The free response questions are further divided into 2 categories. One is the basic FRQs, which are spread over the entire syllabus. But then there is one special question, which is part B, which is the longest question of the test, known as the investigative task. So you can say that in a way, this one question is like a summary of the entire syllabus. All the important concepts that you learn as part of the entire AP syllabus, they are covered in this investigative task. So this one question you get 25 minutes to answer, and it contributes, you can say, almost 30% to your score, that one question, 25% score actually. Okay, so overall the weightage is 50% for MCQs, 50% for the FRQs. Now, if we talk about what is a good raw score, I hope all of you do know that on the AP, the final scores are graded scores on a scale of 1 to 5, okay, where 5 obviously represents maximum proficiency in that subject. So obviously, all of us are appearing or taking this AP examination with the sole purpose or aim of getting a 5, right? So if we want to get that 5, what do we need to do as part of our preparation? So I'll be explicitly talking about the preparation strategies later on as well. Okay, but looking at that test structure, some things that we should understand very clearly. We must prepare separately for the MCQs and FRQs. That is abundantly clear because they carry 50% weightage. So you must know how to attempt a multiple choice questions, that is, make use of the choices. And you should also know how to write detailed answers to a particular question, which is the FRQ. Now, because both of them have equal weightage, you need to focus equally on both the sections, the MCQ as well as the FRQ. Now, a score of 5 usually is equivalent to a raw score of 65 to 70% score. Okay. So if you're looking at, let's say, the total examination marks are 100, your aim must be to score somewhere 65, 70 and above. Okay. So if you end up getting a score of 65 and above, most likely it is a 5 on the actual AP test. Okay, it is a 5 on the actual AP. If you end up getting a 65 or a 70 or above, it's a score of 5. Okay, if you are in the range, let's say 55 to 65, you would end up getting a 4, and below that, then it would be a 3 and then a 2. Basically, we don't want to be in that zone at all. So one thing from the strategy perspective I can talk about right now, all of you who are going to take the AP examination, you must decide as to how much are you going to score, or how much you would need to score in the MCQ part and how much you would need to score in the FRQ part, so that collectively you are scoring more than 65-70%, so that it ensures you a score of 5 in total. Now, coming to some sample questions from these examinations. Now, I have deliberately chosen the sample questions which are already shared by the College Board, so that it gives us the taste of actual questions from the test. Okay, so these are some sample multiple choice questions. So you can see that all the units basically find a representation in the MCQ section. For example, this question, it says, which of the following histograms has a shape that is approximately uniform? So here we are actually focusing on unit number 1, representation of the data. Okay, and this is obviously a one variable data. You can see that it's a histogram which we need to analyze. Now, on the histogram, y-axis, you can see there are relative frequencies, or the percentage frequencies, so as to say, and there are and there are variable, or there is this variable on the x-axis. Now it says which of the following histogram has a shape which is approximately uniform. So a uniform distribution would mean that almost all of those bars are more or less close to a fixed value. So we can clearly see of all the 5 diagrams, the first one, all the bars are more or less in the range 0.1 to 0.12. So therefore we can say that that one, the first option, is approximately a uniform distribution. The other distributions, you can clearly see the values fluctuate a lot, right from a 0.05 to a 0.2. There is plenty of fluctuation. Therefore, they cannot be treated as uniform distributions. Second question is from the theme probability. It says a recent study reported that 45% of adults in the United States, they now get all their news online. So a random sample of 8 adults in the United States will be selected. What is the probability that 6 of the selected adults get all their news online? Now, when we study probability and probability distribution, we study something called as a binomial probability distribution. This particular question is actually from the binomial probability distribution. So how do we calculate the probability in case of binomial probability distribution? We have this formula for binomial distribution, NCR p raised to power r 1 minus p raised to power n minus r. Okay. So if we just follow that formula here, we have to have 6 of the selected adults. So total adults 8, out of which I need 6. So 8C6. The probability is already given to me as 45%. So 0.45, okay, raised to the power, this one is n minus r and this one is r. So 0.45 raised to the power of 6, and then 1 minus 0.45 would be a 0.55 raised to power 8 minus 6, which is a 2. So if I look at all the options, it's pretty straightforward that the correct option here is option number D. Okay. So most of the questions on the MCQ part, you would see that they are based on some or the other formula here. Now, the good part about these formula is that all of these formulae, they are given as part of the formula sheet of the examination itself. Okay, so you have the formula sheet available to you in the question booklet itself, and therefore you don't need to cram these formulae. They are available to you in the question paper itself. So this binomial probability formula is also available in the question booklet. You just have to refer to the formula, substitute the relevant values, and then find out your answers. All right, let's move to the next one here. So another of the units being touched here, as you can see, this question in particular is based on the unit of statistical inferences. So it says in 2011, 17% of a random sample of 200 adults in the United States indicated that they consumed at least 3 pounds of bacon that year. In 2016, 25% of a random sample of 600 adults in the United States indicated that they consumed at least 3 pounds of bacon that year. Assuming all conditions for inferences are met, which of the following is the most appropriate test statistic to use to investigate whether the proportion of all adults in the United States who consume at least 3 pounds of bacon in 2016 is different from that of 2011? So this question is based on a particular inference which is called as difference of proportions. That earlier there was some proportion which used to consume bacon, and now there is some proportion which consumes bacon. So are they statistically different? So I want to check this particular difference. Okay. So for checking this difference, we use a statistic which is called as the Z statistic. So in the Z statistic, once again, there is a formula which would be available in the question booklet itself, which says that the Z is equal to the difference of the two proportions divided by what is called as the standard error. Okay, so if I am calculating that standard error, I use something which is called as a cumulative a cumulative estimator of the proportions, okay, which is called as PCAP. So earlier there were 17% out of 200. So 17% out of 200, if you will calculate, it is equal to 34. And then it was 25% of 600. So 25% of 600 is 1/4. If you calculate that is 150. And the total is 200 and 600. Okay. So all in all, if I calculate that, it is 184 divided by 800. Okay. So it's a pooled estimator, as we call it, of the proportion. Or you can say it's an average estimator. So this thing comes out as 0.23. So when we apply that concept of standard error, once again, as I said, it is a standard formula. So it will be the difference of proportions, which is 0.17, 17%, minus 0.25, 25%, divided by square root of the pooled estimator here, which is 0.23. Okay, and then 1 minus the probability, or 1 minus 0.23, which is 0.77. And then it is brackets 1 over n1 plus 1 over n2, where n1 and n2 are the sample sizes. So it is 1 over 200 and 1 over 600. So just the formula is being asked. The calculation has not been asked here. So the correct option, once again, we can see is option D. It exactly matches what we have calculated. Once again, a question where I just was required to refer to a formula given in the question booklet, substitute the relevant values, and find out my answer. All right, let's move to the next one here. So in a recent year, the distribution of age for senators in the United States, okay, was unimodal and roughly symmetric, with mean 65 years and standard deviation 10.6 years. Consider a simulation with 200 trials in which for each trial, a random sample of 5 senators' ages is selected and the mean age is calculated. So which of the following best describes the distribution of 200 sample mean ages? The important or the keywords here is that the distribution is unimodal and roughly symmetric. So when we are referring to a unimodal and roughly symmetric distribution, in statistics, it is called as the normal distribution. So yes, the distribution is approximately normal with a mean value of 65 years, but it is given here that the standard deviation value is 10.6 years. Now, when we study sampling distributions, and if the sampling distribution is normal, okay, the standard deviation of the sampling distribution is called as the standard error. So what we need to calculate here is standard error. And again, it is very simple. It is the standard deviation divided by square root of n. Another result which is present in the formula sheet on your AP examination. So here the standard deviation is 10.6. You divide it by square root of the sample size. So square root of the sample size, you can clearly see it is just a square root. It is just a square root 5. So sigma by root n would be 10.6 over square root 5. So we can say that our distribution is approximately normal with mean of 65 years and standard deviation 10.6 over square root 5. Another question, as I pointed out, which is directly based on formula. Moving on with some more questions here. If you have any doubts, okay, please post your doubts in the comment section. I'll be more than happy to take all your questions once I am done with this basic presentation. So you need not wait, to post your doubts in the very end. As and when you have doubts, just keep them flowing in the chat box. Okay. Next question. An athletic director believes that more than 50% of students in a certain school district exercise at least 3.5 hours per week. So to investigate the belief, the director selected a random sample of 40 students in the school district, found that 60% of the students in the sample exercise at least 3.5 hours per week. So let P represent the proportion of all students in the school district who exercise at least 3.5 hours per week. Which of the following is most appropriate alternative hypothesis to test the director's claim? Now, this is based on the basic concept of hypothesis testing, where we have two types of hypothesis. One is called as the null hypothesis H0 and one is the alternative hypothesis HA. The basic theory of hypothesis testing says that we test any hypothesis for rejection. That means if there is a researcher, he will frame the hypothesis in a way that he wants to reject the status quo or something which is already present, and therefore what he actually wants to prove would be taken as the alternative hypothesis. Remember, hypothesis testing is done for rejection. So if I am able to reject the null hypothesis, then only the alternative hypothesis can be considered as an alternative for the null hypothesis. So obviously here we can clearly see that the director believes that more than 50% of students in a certain school district exercise at least 3.5 hours. So more than 50% means he believes that the proportion must be greater than 0.5. So what he believes would become the alternative hypothesis, and therefore he has to reject the null hypothesis that it is actually less than or equal to 0.5. So if the question was about what would be the null hypothesis, the null hypothesis would be proportion is less than equal to 0.5. The alternate hypothesis would be the proportion is greater than 0.5, which is option B. All right, moving on to the next one. For a certain population of penguins, the distribution of weight is approximately normal with mean 15.1 kilogram and standard deviation 2.2 kilograms. So approximately what percent of the penguins from the population have a weight between 13 kg and 16.5 kg? So this is a classic case of calculation of probability from a normal distribution, which looks like this, the distribution. Okay, the mean value is already given 15.1. The standard deviation is also given as 2.2. Okay, so obviously 13 is to the left of mean and 16.5 is to the right of the mean. So the approximate percentage of penguins from the population who have the weight between these two values is actually represented by the area under normal distribution that falls between these two values. Correct? Now, to do this question, you would either need the normal table, the probability table, which is given again as part of your question booklet, but you can also use your calculators directly to find out the normal probabilities. Okay, so any model of basic graphing calculator that you use, be it a Casio calculator, be it a TI calculator, it would have a statistics module, and within that module you would find a function for normal probability calculation. So whenever the mean and the standard deviation is given and you need the normal probability, you can directly do that with the help of your calculator. So if you would refer to the table, or you would refer to the calculator here, okay, the answer to this question would come out to be 57%. So this would be directly done over calculator, which also reminds me of the fact that the calculator policy for the AP statistics test is that a fully functional graphing calculator is allowed throughout the test. Okay, so obviously you don't have to rely on manual calculations. You can always use the graphing calculator, and therefore all the statistics modules, they become very critical for this particular examination. Next up, a researcher collected on the latitude in degrees north of equator and the average low temperatures in degrees Fahrenheit for a random sample of cities in Europe. So the data were used to create the following equation for the least square regression line. So this is based on the basic concept of linear regression. So you can see that the basic equation here is predicted average low temperature is 65.5 minus 0.7 times the latitude. So we can clearly see that the equation is of the form y is equal to constant minus the slope times the x variable. The x variable is obviously your latitude, and the predicted average low temperature is your y variable. So the slope, if you compare the equation, is a negative 0.7. I mean, if you compare it with y is equal to mx plus c or c plus mx, it is negative 0.7. So a negative slope would mean that for a unit change in your x variable, which is the latitude, your y variable decreases by zero point 0.7 units. So 0.7 degree Fahrenheit would be the decrease if the latitude increases by 1 unit. Correct option there, as you can see, is option B, which clearly states the same fact that for each 1 degree north of equator increase, the predicted average low temperature will decrease on an average by 0.7 degrees Fahrenheit. All right. Another one. Now, this is a theoretical question. So there are some theory questions as well, particularly from unit number 3, which is about sampling theory. Okay. So here you can see an independent polling agency was hired to track the preferences of registered voters in a district for an upcoming election. So the polling agency divided the district into 20 regions, and it believes that the regions are similar to one another in their composition. So the agency then randomly selected 2 of the regions and surveyed all registered voters in both the regions. Which of the following best describes the sampling method? So basically, this type of sampling, okay, this is, let's say, your entire polling district, okay, and what you have done is you have divided them into similar zones, okay, so as to say, or similar regions. Now, these regions are known as the clusters here, and therefore, this type of sampling which we are doing following all the cluster is known as cluster sampling. So the correct answer obviously here is cluster sampling. Okay, next one, it says a sports physician conducted a study to investigate whether there is an association between running experience and the occurrence of a certain sports injury for marathon runners while training for a marathon. So data were collected on a random sample of 51 marathon runners. Each runner from the sample was categorized by running experience, low, medium, and high, and whether or not the runner experienced the sports injury while training for a marathon. The condition for inferences were met and a chi-square test statistic of approximately 8.12 was calculated. Which of the following describes the p-value of the test? So this is a question which is based on inferences of chi-square statistic. Okay, and this is called as the test of independence, that whether getting an injury is dependent on the running experience being low, medium, or high. Correct? So for performing these type of tests, we calculate what is called as a critical chi-square value, which is given to us here in the question itself as 8.12. The p-value of the test actually, you can say, is a criteria which tells me whether to accept the null hypothesis or to reject the null hypothesis. Once again, the calculator is available to me, or the chi-square tables are also available to me in the question booklet. So corresponding to this chi-square value of 8.12, I can read the inverse probability values from the table. And for this particular value of 8.12, if we read the values from the table, the significance level is between 1% and 5%. So the correct answer is option D, that your p-value should lie between 1% and 5%. Then the conditions which are stated in the problem would be met. Another question, which is again based on concept of testing of inferences. An agriculture engineer selected a random sample of 30 farms in the United States to construct a 95% confidence interval for the mean size in acres of farms in the United States. The resulting interval was 367 to 558. Which of the following is an appropriate interpretation of the 95% confidence interval? So for that, we should understand what exactly is the meaning of this confidence level here. 95% confidence level, what does that mean? So it's a very basic concept and a definition that we study, that a confidence level, okay, be it 90%, 95%, what does it represent? That if you are going to draw multiple samples of same size, draw multiple samples of same size from this population. So for example, here we are drawing samples of size 30. Okay, so we've just drawn one of those samples of size 30. Suppose I repeat this experiment. I keep on drawing multiple samples of the same size of 30 farms from the same population, which is farms in the United States. Okay. 95% of those samples will give me a value. 95% of those samples will give me a value which would lie between 367 and 558. That is the meaning of the confidence level. Okay, that 95% of the samples that I draw of the same size from the same population will have a parameter value between 367 and 558. So that 367 to 558 is called as the confidence interval. 95% is called as the confidence level. So if you look at all your options here, option number D is exactly the same. Approximately 95% of all random samples of size 30 from the population will produce intervals that contain the mean size of farms in the United States. That I'm going to get intervals which would be in the same range of 367 to 558. Some more, an experiment was designed to investigate the relationship between the dosage of a certain migraine medication and the amount of time until relief from the headache was experienced. So 4 dosages in milligrams, 2.5, 5.0, 7.5 and 10 of the medication were used. There were 20 participants in the experiments. Okay, they are known to experience migraines. So each participant was randomly assigned one of the 4 dosages. When the participants experienced a migraine, they took the assigned medication, recorded the number of minutes it took to experience relief from the headache. So the mean number of minutes it took each group to experience relief was then compared. What were the experimental units? So remember, this is a question from experimental design again, very theoretical in nature. Experimental units are strictly defined as the subjects that undergo this experiment. So in this case, obviously, the subjects are the 20 participants which are undergoing this particular experiment. So they are known as the experimental unit. Simple answer here is option D, the 20 participants. At a small company, 40% of the employees are classified as junior level, 32% work in department A. Of those classified as junior level, 55% work in department A. One employee will be selected at random. What is the probability that selected employee works in department A and is not classified as junior level? So this question is a core probability question, and it can be easily done if I just draw a contingency table 2 by 2 for the given data. On one side, I will classify it as junior level and not junior. On the other side, I will classify as department A and does not belong to or not department A. Okay, so the data which is given to me is 40% are junior. Therefore, I can say 60% are not juniors. Okay, similarly, 32% are belonging to department A. Therefore, I can say 68% do not belong to department A. That is the breakup of 100% row wise and column wise. Now, in the question, they say 55% of the junior level employees work in department A. So 55% of 40%, if I calculate that, so 55% of 40%, okay, I think that would work out to be okay, that would be 22. So this figure here is 22. Therefore, this figure here is 10. Okay. So the question was, what is the probability that selected employee, okay, is belonging to department A but is not a junior? So obviously that is 10 out of 100, which is 10%. The correct answer is 0.1. Okay. So those type of questions are very common on the AP examinations. We can have a quick look at a free response sample question as well. Okay. So in a free response questions, obviously you have to write the answer to all the questions here. So for example, past records from a certain movie theater indicate that 80% of moviegoers make a purchase at the movie theater snack bar. So random sample of 3 moviegoers from that theater will be selected at random. Let the random variable S represent the number of moviegoers who make a purchase at the snack bar. from the 3 selected. So complete the following table to create a probability distribution. So once again, as discussed earlier as well, this is a classic case of binomial distribution, okay, where your n is 3. So I can actually calculate the values corresponding to favorable numbers being 1 or 2. So the first probability would be 3C1. 0.8 is the probability raised to power 1 times 0.2, 1 minus p raised to power 3 minus 1. If I calculate that, I get a 0.096. Also remember, this you can directly do with the help of a binomial probability table, or you can directly do on your calculator, which allows you to directly calculate the binomial probability. So I need not even do all of this. I can directly find this 0.096. So this one here will become 0.096. The second part of the question here, 3C2, it will be 0.8 to the power 2 and then 0.2 to the power 3 minus 2. If I calculate that part, this comes out to be 0.384. So I fill all these values here. The second part says calculate and interpret the expected value of S. The expected value basically is nothing but the mean value, and it is equal to summation of S multiplied by P of S. That means I take each one of these S value, multiply it with the corresponding probability value, and then I find the sum total of all these S times PS values. So if I multiply column wise and then I add all of them together, okay, I will get the expected value. So that expected value comes out to be 2.4. So it says calculate and interpret. So how do I interpret this 2.4? So this 2.4 is the expected number of moviegoers who would make a purchase at the snack bar, okay, while going to the movie. So this is the expected number out of 3 who would make a purchase at the snack bar. 2.4 out of 3 would make a purchase at the snack bar on an average. So that is your expected value concept, right? So these are the type of questions you are likely to see on the test. The preparation strategies I have already talked about, that we need to prepare separately for the MCQs and the FRQs. You need to understand the concepts very well. All the concepts related to probability, inferences, hypothesis, the concepts must be absolutely clear in your head. So you should pay extra attention to develop sound concepts and fundamentals of the subject. You need to familiarize yourself with the pattern of the exam, because you need to strategize, as I said, as to what is going to be the breakup of your score in the MCQ section and the FRQ section. You must utilize the available resources like the calculator usage. You must do a lot of online practice and make use of good books. So if you have any questions, I am free to take those questions now. Any doubt in your mind related to the exam, related to the prep, whether I should be taking it, not taking it, please feel free to post all your queries in the chat box and I'll be happy to answer all those questions. Okay, it says what is best class to do exam after 10th or 11th? All right. So my suggestion would be the best time to do this would be after 10th. Okay. After 11th, I think you would be more inclined towards taking other APs like the calculus one if you are into mathematics, or if you are into other subjects as well. I think you would want to take other APs after 11th. So the best time as per my calculation is immediately after 10th. You can opt for this particular AP. Yes, please. Other questions? How do you rate in terms of difficulty? Well, I will say it is not as difficult as the AP Calculus or an AP Physics C course. So my rating would be that this is a moderately difficult course. It's not very easy, but it's not very difficult as well. It's, let's say, on a scale of 5, if I have to rate it, I'll rate it something like a 3.5. Okay. Is above a 70% considered as a 5? See, it is a 5 on the test. The schools don't give you grades on the AP. The college board gives you that grade. Once you've got a 5 from the college board, every school will take it as a 5 only. So it's a standardized grade. So therefore, it is going to be a 5 throughout if you get it as a 5. All right. Any further questions? Right. So if we don't have any further questions, so then I would like to hand it over to my colleague Kanushri, who would be taking some more of your time and talking about the course and other things related to the same. Over to you, Kanushri.
Thank you so much for a wonderful session, Harsh. Um, I'd also like to share some of the AP results with you. Here they are. Also, we host unique AP masterclass every weekend, and we'll be sending out email updates to keep you informed. That brings us to the close of today's session. I'm sharing some important links in the chat box. Please feel free to save them. Okay, there you go. All right. Please scan the barcode for one-on-one interaction. Thank you once again for joining us today. Until next time, take care and keep learning.